welcome everyone. If you can hear us, if you can see us, please set the thumbs up in the YouTube chat. We will know we can start. Hi, Stefano.
Hi, Alex. Hi, everyone. Welcome to today's workshop, Introduction to Apache Cassandra for Developers. Yes, as Alex said, please tell us if you can hear us.
Yeah, so looks like we are good. Yeah, looks
looks
good
like
on
we're
my
good.
side.
Very good.
Right.
So let's start.
Let's start. Let's
I
start for
think
sure.
you are showing your screen, so
That's
you
right. So
might.
I'm going to switch to yours, actually. Give me a
Yes,
moment.
sure.
Boom.
Yes,
You
I
are
see
live.
lots of thumbs up, so great. Oh, there we are. Okay. So welcome to today's workshop, Introduction to Apache Cassandra. I'm Stefano, developer advocate at Datastax. I like Apache Cassandra, I like distributed systems, and today I'm also here to teach you something because I love to teach. These are my social contacts, so you are very much welcome to connect with me. Alex here on my left, please
Right.
introduce yourself.
So I'm Alex Voloshev, developer advocate at Datastax, and I actually enjoy all of our workshops. Maybe some of you have seen us before. If you didn't, then you are lucky enough and welcome to this team. Enough of words, let's move on.
Let's move on.
Yeah.
Because it's not only the two of us, but the whole developer advocate team at Datastax is, you see lots of people, and they are usually behind all of the work we do. So it's teamwork, and some of them might also pop up here today in the chat to help if you have questions. Speaking of questions and interaction with you, a bit of preliminary information. Today we are streaming on YouTube, but in the very uncommon case that YouTube has trouble, which happened just yesterday after 1 year of everything going fine, we will switch to Twitch as a backup plan. So get ready. We have some plan B in case there are trouble, but hopefully today it will work on YouTube. There is quite some interactivity in this workshop, which has various forms. One is the chat box you see on the right of your YouTube live window. So this is a place to interact with us and ask questions and everything. And we are trying to keep an eye, and usually we try not to leave any questions unanswered. But that's not the end of it, because we are also we have an active community on Discord, and actually maybe we can ask our good old Nightbot to drop the link to it. So you should see in a few seconds a link to the Discord server of DataStax developers, which you are invited to, because that is where the discussion can go on even after this live is over. And the topics covered there range from very widely between app development, new technologies, obviously NoSQL databases, and Cassandra in particular. And we are there to help you and chat, discuss, and answer your questions. That's not all of it, because we are also having an interactive quiz and games during today's workshop. And by the way, the last part will be questions with timing, and the fastest answers will win prizes. So please don't forget about Menti. We will come to that in a little while. Now, more to the point, today is an interactive workshop, so we will be introducing you to this wonderful technology that is the database Apache Cassandra, and you will also be able to do something by yourself, so some hands-on exercise. To do that, don't worry, you don't have to install anything, because it's all done in your browser, thanks to technologies that are available in the cloud. So first thing, we have a GitHub repository, and I think it's a good time to drop the link to it in the YouTube chat. We have a GitHub repository containing today's slides, source code, which today means SQL commands to run, to execute. So you will see later what that means. and indicate and instructions to perform the exercises by yourself. Because the idea is that the GitHub has a big README that explains everything and enables you to do the practice and to learn on your own, even if you, for some reason, are not keeping up with today's live session. So you can go there anytime and do the practice by yourself. But obviously, we need a database. GitHub is not enough. And the database today, again, lives in the cloud for you. So we will be using AstroDB, which is a database as a service offered by Datastax based on Apache Cassandra, and that will make it possible to play with the database without having to worry about operations, maintenance, installation, anything. And the sweetest part is it is free up to a very high level of usage, which very much covers what we will do today and much more. So I see questions in the chat. I have no background in NoSQL. Am I a good fit to attend this workshop? Yes, and even more than yes, because this is, again, an introduction to Apache Cassandra. And I would say Cassandra is one of the coolest NoSQL databases. So you are very much in the right place.
All right. And I would add a thing here. A lot of people consider NoSQL as something monolith. There are a lot of SQL databases and they all similar to each other from a developer's point of view. And then you think, oh, NoSQL, so there are a group of databases very similar to each other. And that's completely wrong because they're very, 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 very different. So if you know Mongo, it won't help you with Cassandra because Cassandra is different. If you know Cassandra, it won't help you with GraphDB like Neo4j because they are different and things like that. So you are totally welcomed.
Yeah, absolutely. Indeed. NoSQL databases share one thing, that they are not relational databases. That's about it. So then there is very much variety within the NoSQL family. Now, that's not the end of it, because we would like to help you brag about your achievement. So let's say you follow the workshop, you're interested, and you manage to do the exercise successfully. Then we want to prove that. We want you to be able to prove it. And that's why we have a program of badges, verified badges offered by Badger.io, I think, right? Badger.io, if I remember correctly. And we will have some homework for you to do at the end of today's workshop. You can submit the homework anytime in the next days, let's see, and we will grade them and we will award you a nice badge that you can then use in your social profiles and post about it anywhere. And yeah, be the cool guy who can prove their knowledge of Cassandra. That's not the end of it. So let's speak a bit about the homework again. Homework will be a bit of exercises by the end of today's practice. And there will be also 2 very cool interactive scenarios that you can go there and play with in the browser. So you will be given the opportunity to learn even more about the SQL language, which is the basic language to interact with Cassandra, and the data modeling process, which is one of the most important part of using Cassandra. They are very cool interactive scenarios. You can do them, and they contain exercises, and they guide you along doing exercises. So I think that's a good time to switch to the first interactive part of today, which is just not yet the quiz with prizes, but just a few questions to get to know you better. So without further ado, I would invite you to go to menti.com, possibly with your phone, and there you will establish connection with our questions. So to go to Menti, please take your phone, go to menti.com and enter the code that you see in the chat, and which will very soon...
Give me a moment.
Yes.
Yep, and enter the code you see on the screen.
Yeah, the code is also in the YouTube chat, and you will, now you're seeing that on screen, or you can use the QR code on 404 on the GitHub link. Let's see. That's very unexpected, but I'm going to check. Let me check.
Meanwhile, anyway, join the Menti while we are checking the GitHub link. But last
That should
time,
work.
that should
Let's
work.
see. Let me paste it manually, maybe. No, okay, I think it works. But anyway,
Yeah, it works.
I'll
It
paste it
works.
once more. So please keep this repository open because it will provide guidance and also help you navigate through the various commands that we will later ask you to run in your own database.
Now we will ask you. Now we will ask you a few questions. Yeah, it's totally fine. We don't yet ask the questions. That's all good. We will ask you a few questions. No rush. But in the end, using the same Menti, so don't quit after the questions from Menti. We will play a game with the prizes. So stay with Menti or jump in right now. And meanwhile, I'm starting the first question. Where are you guys located? Where are you from? Where are you now? Okay, I see India, I see United States, UK, or is it Ireland? I'm not sure. Again, United States, that must be Canada. And
Yeah.
that's definitely Africa. That's amazing. You know what? We do educational trainings for a few years already, and I'm happy to see how we have more and more people from different regions. I mean, we always have a lot of attendees from India, for example, but it's great to see what we now have, getting more and more attendees from Africa. That's just very
Yeah.
cool. Thank you for joining.
Yeah. So just a warning. I see many answers in the YouTube chat. That's unfortunately not how it works. So you're supposed to go to menti.com and put your answers there because otherwise they are not processed. And that's not a big problem now, but when we will then go to have the quiz, the game quiz, if you answer in the YouTube chat, you will not have a chance to win. So winners make points only by playing within menti.com. We don't have any integration between the YouTube chat and this Menti platform, sorry. So please remember to join Menti for the later questions.
Good. Then next question, what's your experience with NoSQL databases? We have a couple of people with a lot of experience, which is great. And most of you, of course, are beginners in this field, which is totally fine. We have a dedicated workshop for introduction to Apache Cassandra. You're attending right now. We also have very interesting workshop introduction to NoSQL, which explains the variety of different NoSQL databases, how they support each other and how they compete. And they also invite you to attend it. So I believe that's quite interesting. Yeah, most of you never use it or have some experience, but not too much. That's cool. Then
That's the
basically,
right place for you.
right place for you to
Yes.
be. Welcome. Are you a certified NoSQL and or Apache Cassandra expert? I mean, are you certified maybe with any another NoSQL databases, not only Cassandra? Okay, we have one certified person. Two. Okay, that's getting better. But most of our attendees are not certified in this field. And well, that's pretty much expected.
That's
Then
why
that's
we have
why we
good
have
news.
good news. Right, DataStack sponsors your education and certification as a NoSQL expert. And that is really cool, and I like it a lot. We will give you more details in the end of this workshop. But for you to know, with DataStax, you can get your education for free in the NoSQL field, get your voucher in the end of this workshop, and then take an exam and pass it, hopefully, if you learn thorough enough, and become a certified NoSQL expert without paying a cent. Isn't that amazing? Yeah, I do believe that's quite amazing.
Yeah.
So that was the last question for the setup. And Stefano, I'm switching back to your screen. Give me a
Yes,
moment.
absolutely.
So,
But please keep the
boom.
Menti open because this very same connection to Menti will be used for the quiz. So don't close it yet
Right.
if you want to play the game and have a chance at winning prizes. Okay, but I think it's now time. Now we have met. We have gotten to know our audience a bit better, I think it's time to try and have a closer look at this Apache Cassandra thing that we are about to see. What do you think, Alex?
Sorry?
I think it's time to have a closer look at Cassandra.
Yeah,
We've been
sure.
speaking so far, and now it's time to get into the meat of the thing. So, Apache Cassandra, what is that? Well, it is a NoSQL distributed database. And when I say that, every word here has a very important meaning. So let's see. It is a NoSQL database. So what is a database? I can imagine most of you know what a database is. It is a technology able to let us store and retrieve data in a well-organized way and hopefully performant way. And so far, so good. Cassandra is NoSQL. That means that it goes beyond the very good and well-established paradigm of the relational databases. So it is approaching storing of data and managing data in one of those new ways that we just remarked. NoSQL is not a type of databases, but it's rather a whole philosophy, a whole set of different ways of not implementing relational databases, basically. And the important thing is that Cassandra is distributed. So it has an approach where the data is stored on several nodes. Just one point, I see in the chat a question, do we have a recorded session for a later reference? Yes, very much yes. That all of our workshops will be available later as recordings at this same link you are watching now. So you can also, by the way, you can also browse our DataStax developers YouTube channel, and there are lots and lots of videos on all topics, including this video here. Okay, so let's go back to Cassandra. It is a distributed. That means that Cassandra, as many computer programs, lives in a machine that we call node. So you install Cassandra on a given node, and that means that this node can host, let's say, a few terabytes of data. And since it is designed in a very well-performant way, it is able to support a lot of transactions per second per core. So you have a multi-core machine, you have more transactions. Now, when we say transactions, let's say read and write operations. I'm not speaking of transactions in the transactional sense of relational databases. So just read and write, a lot per second, something like a few tens of thousands per second per core, usually. But what is very powerful in Cassandra is the way it approaches distributed data, because the whole Cassandra database is not just that one node, but it is a whole set of nodes. You see, they are now many nodes. It's 7 of them. It might be even very many more than 7, and each one is running Cassandra, and they collectively form your database. So the data lives distributed, scattered in a very precise way throughout all of these nodes. These nodes speak to each other according to several protocols. In particular, one of the most important is the gossip. That is what makes every node aware of the other nodes, how they are, who they are, and where they are. So that the interaction between those makes it possible to look at the database as a single thing from outside, even though internally it's a distributed system. These nodes together form what is called data center, or we usually call it ring, which for us today is the same. And you might wonder who is using Cassandra. So what kind of performance or data size can Cassandra support? Well, good news is that Cassandra is now a very well-established database. It is more than 10 years old. It's been developed for a long time and optimized and improved for quite some time. And it is used by some of the largest IT companies in the world. So the names of Apple, Netflix, if you ever used an Apple product, Netflix product, if you booked an Uber ride, and I don't know if you use, also GitHub is using Cassandra, for example. So let's say these big names speak about the reliability of this database, because these are companies that cannot afford failures or downtimes much. And they also deal with data at a scale that is almost astonishing. So you see the numbers here. This slide is from I think a Cassandra Day, or maybe an Accelerate event a couple of years ago. And you see there are clusters made by hundreds of thousands of machines, of nodes. They host collectively several hundreds of petabytes, and they support a number of operations per second that is very, very impressive, I would say. So this is just as a testimony of how Cassandra can be powerful if properly handled. And yeah, so let's have a closer look at some of its main properties. So Cassandra is a NoSQL distributed database. We know that. It is also decentralized. We will see later what that means. Let's say that, as you briefly saw in previous slide, it is able to accommodate big data. So if you have clusters made by, let's say, tens of thousands of nodes, and every node can host a few terabytes of data, you can do your multiplication and figure out that we can easily reach petabytes and petabytes of data. Cassandra is optimized for very high performance in reading and writing. So due to the way due to its architecture, it is able to support very fast reading and writing. In particular, writing, and I say that just because for most databases, the architecture is a bit skewed to fast reading, but not necessarily fast writing. Cassandra takes a different approach and makes also writing very, very, very fast and performant. So Cassandra, due to its architecture, can scale linearly. That means I think we have separate slides on these points. So maybe I can just jump forward. So let's just mention that it is a database that can scale linearly to virtually any size of cluster. It can be configured to have the highest availability. It is able to self-heal, and most of the procedures to adapt to disruptions is automated. It supports geographical distribution, so it can be spread all over the world. A single database can be spread all over the world. Well, linearly does not mean horizontally, but yes, we are speaking of horizontal scaling, but we will come to that in a second. Blackleg. It is platform agnostic, so it will not how do you say, fence you in a single cloud vendor, and it is open source. So let's go to a few of those points. So big data ready. Data is distributed and partitioned over this distributed architecture, several nodes. And you know what happens if you need more data because somehow your application is growing? You just add more nodes. So you can just scale horizontally by adding more and more nodes. And Cassandra is optimized to run on commodity hardware, so you don't have the astronomical cost of very powerful, dedicated special purpose machines. You can easily just add more and more ordinary machines. Then you have a very good read and write performance. I think we said that already, but in particular, the way reads and writes occur is not coordinated by any centralized entity. So even if on a very large cluster, you will have very fast reading and writing. In particular, you have constant time access regardless of the size of your cluster. So if you have this ring made by 6 nodes, you have the same access time as if you had 600 nodes, which is a remarkable achievement. Then there was a question about linear scalability. Now, by linear, in this case, we mean that if you increase the number of nodes, in general, you will expect some increase in the performance. In particular, for example, the amount of read-writes that your system can support Now, usually there is a less than linear increase. So let's say you double the number of nodes, and in many systems you have a bit less than twice the performance available. On a very wide range of cluster size, Cassandra is surprisingly linear. So if you double the number of nodes, you actually get double the performance available. And that's as good as it can get, because something super linear, I don't think it can exist. Alex, what do you think? You would like to have a super linear system, so you double nodes and you have 3 times as much performance, but I think that's something that is not in this universe. But even having it linear is not bad. So another important point is that Cassandra offers the highest availability. So you can have data is replicated over several nodes. Not only that, but you can have a single database spanning several physical locations, and with the inter-data center replication also automated, which is the highest availability you can design. And actually, if you design your cluster and your database in the right way, you basically achieve a 100% uptime, theoretically. So even just a very widespread Earth level disaster can make your database not available, nothing short of that on that. And the important point is that there is no a master node. So every one of these nodes, every one of these rings that form your database is active. So there is no a primary and then a lot of replicas just read only or anything. Every database of these, every cluster of these will be able to support reading and writing. And as I like to say, all nodes are created equal in Cassandra. So there is no master architecture of any kind. There is no concept of master.
And there is a point someone mentions, there are coordinator nodes, and I want to explain every node is a coordinator node.
Yes, so there are coordinators, but it is not a fixed role like this node is the boss. Every time a single query arrives, there is a query coordinator that coordinates that one query, and then after that, it will go back to having the same role as any other node. So every node can temporarily act as a coordinator for a single query, reading or writing. Okay, so another very cool part is that we all know, at least many of us know, that operations and management and maintenance of databases can be a very heavy and daunting task. Good news is that Cassandra is mostly able to take care of itself, so to speak, under many circumstances. So if you have, in particular, if you have to scale out, for example, you have to add more nodes, most of the underlying data redistribution is happening automatically behind the scenes for you. I see a question about hashing. We will come to that later. The answer is yes. For distributing the data, yes. Now, let's go to the geographical distribution point. Cassandra is designed from the ground up to support multi-data center databases. As you see in this picture, we have a database in California. We have a ring in California. We have a ring in Europe and one in Asia. And they all form a single database. They communicate to each other asynchronously behind the scenes, and they ensure consistency. And this all happens basically by design, and you don't have to worry about that too much. And it will guarantee that your data is everywhere. And in particular, if you have customers in various continents, that's very important because you want to offer low latency to all of them. So, and yeah, a remark here is that all data centers forming this database are active. So it is an active setup. No read replicas or anything. No fallback replicas of any kind. They are all the active part of your database. Another important point is that Cassandra can run on every cloud provider or even on your own premises. And a single database can also be deployed in a hybrid way. So if you want to have maximum resilience, you can have your database spread over several cloud providers, a bit of AWS, a bit of Azure, and so on, and it will still be a single database. So geographical and cloud provider independence. Last point, very important, is that Apache Cassandra is an Apache project, so it is covered by the Apache license, and that will guarantee that you will never be locked in any way, which is cool. Probably you know of many Apache projects, at least Spark, Hadoop, Zookeeper, Maven, most of you. So let's stop here for a second. I've seen the YouTube chat popping up with questions. So Alex, have there been interesting questions that you want to discuss
There
for
are a
everyone?
lot of questions
Yes.
about consistency. How, in general, it's all about how consistency is being maintained if it's the active distributed system. We explain it later, so I don't want to stop on it right now. Is it possible to keep data locally restricted for GDPR reasons? Yes.
Yes.
And yep. So that's a primary. In general, I'm answering questions on the YouTube chat. And if I somehow miss your question, then let us meet later on Discord.
Yeah. Very good. So I think I hope I piqued your interest with this description of Cassandra. I think it's now time for you to do some hands-on part and get your hands dirty. So get ready for your first hands-on session. What will happen now? You will be creating your own database in the cloud, and it will be a Cassandra-based database for later playing with it. Now, I see a very valid question in the chat. What is AstroDB? Well, let's make one step back. AstroDB is a database offered in the cloud as a service by DataStax, and it is based on Apache Cassandra. And you will basically be able to spin up your own Astra database in the cloud in a few clicks, in a few minutes, and you will be able to use it later as if it were your own Cassandra installation on your local machine or wherever you want, with the advantage that it will take a few minutes to set it up. So today for the exercises, otherwise we will take the whole workshop just having you install Cassandra on your machines, which we don't want to do. And it will basically be managed by DataStax for you in their own cloud machines, thanks to the magic of Kubernetes, by the way, behind the scenes. So what is AstroDB? Is a database as a service offered for free to you by DataStax. And you will use it today to play with Cassandra a bit. And then we hope you will be starting to use it to create who knows which wonderful application. So there's a question, you will see it later. Jamshare, AstroDB is multi-cloud, so you can choose the cloud provider and it will be deployed on that one. So AstroDB allows you to put your data anywhere, choosing the region and the cloud provider. This is in answer to Jamshare, by the way. You will not have the burden of operations because that's all handled for you as a service in the cloud. And there is a free tier, that's to answer Ashkai Agrawal. There's a free tier that affords you 20 million reads writes and 80 gigabytes of storage per month. So actually, for very heavy workloads, that's a paid product. But today, and for a reasonably sized small scale application, you will be staying within the free tier. That's because you will have a monthly credit for free to use. If you want to go on and keep using Cassandra, which we encourage, and using AstroDB, you can still stay on AstroDB and play with it and even set up your own application and let it run forever. And as long as you stay within these bounds, it will be free. So yes, it's completely free unless you are really running an enterprise level kind of thing. So the link to the GitHub repo you already saw. And then I think it's time. Alex, what do you think? It's time for the first part of today's hands-on. So I think you can either scan the code or type the link you see here, or it should appear in the YouTube chat in 2 seconds, but maybe I can paste it. For some reason, there is some delay. So
yeah,
here,
here we go.
okay, just took a few seconds. So if you click here, maybe you can start registering, but probably Alex might take over with his screen at this point.
Right, that's what I'm going to do. So, ladies and gentlemen, in the next few minutes, I'm going to be your best friend because we will walk through the first exercises working with Apache Cassandra. We don't want to make you install Cassandra on your laptop because it's going to take quite some time. And that's an introduction for Cassandra for developers. We will use Cassandra as a service in the cloud because it's already deployed there by us for you. But basically, all the exercises we do today, you can do with your own locally running Apache Cassandra. It's, of course, totally supported. And yes, as our dear Stefano just said, spending 5 minutes on that, yes, it has free tier. So let us go on and let me switch to my screen. Boom, 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 boom. Right, boom. So now most probably you can see my screen. And that's our workshop. And I will again put the link to you in the chat. Right. Yes, you do have to create an account. Please create an account following the link astra.dev/12-16 as it was pasted in the YouTube chat already. So please create an account. Again, this scenario, this workshop is totally free and you don't pay for the Astra usage. Actually, you can use Astra even for small production workloads without paying for that. So, first thing you have to understand is that our workshop Intro to Cassandra GitHub repo, which you will use to do all the exercises. And you can do those exercises right now together with me, or you can do it later on your own, asking questions at our Discord server as well. And let us start. So first part of our exercise will be to create your AstroDB instance. So you register at Astra and choose Start Free now to start on a free tier, and that will be enough. When we have to create a database, and we will walk you through that. So I already have my, oh, okay, sign it out. I will sign in back. Okay, I already have one data. Let me make it a little bit bigger for you. So you will get this screen to create a database immediately because you don't have any, at least most of you, and I will just push the button, create a database. Now I will create a database following the instructions of the workshop. I will use for the database name workshops. And by the way, I will paste it to the YouTube chat to make it more comfortable for you. I told you I'm your friend. And then as a key space name, we will use Cassandra. At this moment, don't ask what is a key space. We will explain it soon. Now we have to select a provider and region. And as a provider, you can choose between Google Cloud Platform, Amazon Web Services, and Microsoft Azure. And now please tell me which cloud I should use. Just write on the YouTube chat which cloud I should use for this demo. It doesn't matter because Astra and Cassandra runs on every of them. But frankly speaking, for us, it doesn't matter because Astra provides this abstraction layer. AWS, AWS, Azure, AWS, AWS. Okay, guys, so Google Cloud. Hey, Anring, thank you. Actually, you didn't know maybe I'm a certified Google Cloud architect, but as most of you ask for AWS.
Yeah, seems like AWS
okay.
wins.
Hey, Anring, that's how you get banned by our Nightbot. Don't do that. Okay, so looks like AWS has won. And then for the region, I will select Europe, from Frankfurt, as it's the closest region to me. Yeah, AWS is a clear winner. But that doesn't really matter, you will see soon. So I push the create database button, and my database is being started right now. And meanwhile, that's what you can do. As I said, I'm fine if you are doing the lab after the workshop, but you also can do it right now with me. So as you see now, I have two workshops, two databases, sorry, and the one I just created is in pending state. That's totally fine. Now, Astra deploys a new database, new Cassandra database for me, so it will take a minute, something like that. And obviously, we just finished the first exercise, right?
Yeah, maybe we can ask for for a thumbs up in the chat if you manage to create your database and have it in pending state, just to make sure you are following along. So if you manage to get to the pending state, the database being created, you can give us a thumbs up. Yay, yay, yes, that's good. Thumbs up, you guys rock. I take it as a yes, I created it. Yes, 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 yes. A lot of yes. Okay.
Great.
Very good.
Great.
Nice to see it.
There's a question, what's the default cluster size it creates? Frankly speaking, for the free tier, I don't remember. It should
I think it's 3.
I think it's free. I think it's a 3
cluster,
nodes.
I think.
Yep.
I think if you describe a key space, there is a 3 in the replication factor being explicitly mentioned.
Yeah.
So,
you see, when you are on a paid tier, of course, there are more options. No questions. But
Yeah.
you should be good on the free tier for educational purposes, totally. And hey, take a look. My database isn't status active. So that means it's operational. I can connect to it. We see it runs on AWS in Europe Central 1, 0 read request, 0 write request, 0 storage consumed, and 0 data transfer. Not a big surprise because it's just created. We can take a look at its health. It must be in a totally perfect state. So we wait for Grafana dashboard to load and see the status of our cluster. And we see what we are doing well, no request errors. And that totally makes sense because, well, again, there are no operations over this one.
Yeah.
There are instructions on how do you connect to this database using APIs, using drivers for your application, and using SDK. But today, for the purpose of this workshop, we will use SQL Console. SQL means Cassandra Query Language. That's the language you use to work with Cassandra. Quite a surprise, I'm being so obvious today. And that's a console you work with at your browser with Cassandra. For example, I can use help for help, so I can ask for help and get some shell command topics, what I can get with those system. And I can ask, for example, for describe key spaces to ask to see what key spaces I currently have. Do you remember I created the key space Cassandra? It's now key and available for me. So Stefano, do we go for the next slides, or should I proceed? Let's go for the next
I think you
slides.
can stop there on the SQL console, so it's ready for the next steps. And maybe we should jump back to. You will later know what is going on when we do the rest of the practice. So there are a few very quick questions in the chat. One is, can I use Astra for production? And the answer is yes, you can.
Many companies already doing that.
Yes, exactly. So again, it's an offering being used by many big companies. But also, I would say if you have a small workload, you can also use this free tier for production if your application is has a size that fits there. So then maybe it will grow, and if you need to scale, you might want to promote it to a broader, larger level, a higher number of nodes and everything. But still, yes, you can. There is someone, Sajal, wow, it's using Grafana. Yes, there is a tight integration with Grafana. Maybe Alex is the best person to speak about that. Okay. Yes, right. Cedric, hi, Cedric. Thank you that you interjected. Yes, exactly. I was saying the same. So is Keyspace like a schema? Well, Keyspace is...
You will see it soon. You will see
Yeah,
it
okay.
soon.
Let's not spoil the surprise. Okay, so we can move on to a bit more on the internals of how Cassandra works. So,
And let me switch the screen, please. I'm
yes,
answering question. Good. And can we use Python programming language? Yes, totally.
absolutely. There are
But
drivers. Sorry.
no, all good.
No,
Yes,
go ahead.
totally. Yeah, there are drivers, but not in this workshop. In this workshop, as it's fundamentals, we work directly with Cassandra query language.
Yeah.
But of
Yeah, we
course, yes,
start
you
with the
can use.
basics. Yes. By the way, the SQL console is, you have seen Alex writing commands there. It's like many other consoles, even though it's in the browser. You write commands and you hit enter to execute. Just for later, remember that you have to end every command with semicolon. And the good thing is that you have path completion. So you have tab completion. So if you start writing a command, you can, with the tab key, you can have it easily autocomplete. Okay, so let's move on. As I said before this part of the practice, I hope you are now interested, so we can have a closer look at what happens within Cassandra when you use it. So how does it work? Let's start this part. A first important point is that data is distributed. So we mentioned that already, and let's have a closer look. So this is a typical Cassandra node made by a Cassandra ring made by 7 nodes, 7 servers, machines. And on the right, you see a table because, surprise, Cassandra stores data in tables. Tables means that it has so a table has rows and columns. Columns, as you see here, country, city, and population. So this table stores information about cities grouped by defined by a country they live in and the city name, and then there is the population, which is presumably a number. Okay, so this is conceptually, in my mind, it is a single table, but when we say data is distributed, what we mean is that actually, physically speaking, the rows making up this table are spread across the whole cluster. So there are blocks of rows that are on one node, blocks of rows that are on another node, but you see there is there is a property here. You see that all rows in USA are together. All rows in France are together. All rows of Germany are together. And well, many other are just one single row per country, so that doesn't apply. But the point is that the column called country is what is called a partition key. So the value of country will define what is the node which will keep the data, which will host the data. In particular, there is a very important consequence of that. If you have many rows, several rows with the same country, you have the guarantee that they will go to the same node, as you see in this drawing. In practice, when you have a table, every table has at least a column, or maybe more, but usually, let's say one in many cases. And this column is the partition key, and that will define how rows are grouped and how are they stored over different nodes in the cluster, as you see here. So how does partitioning work? I've seen a question earlier about partitioning, so we are now...
Sorry, maybe switch to a previous slide. I
Yeah?
want to add a thing. Take a look. Ladies and gentlemen, a lot of people at this moment don't understand why Cassandra is doing that. I mean,
Yeah.
like, there are many databases that store all their data on a single node, and if they need some secondary read-only replica, they add secondary read-only replica. Then this data is also stored only completely on this node. Why does Cassandra distribute this data divides data into the groups? Answer is very simple. Take a look. Then you have more and more data, your business is more and more successful, you have more and more clients, more and more goods, offering more and more services. At some point, your data doesn't fit into your server, and then you have to replace it completely. Then your data grows again and again and again, and doesn't fit the server, and you have to upgrade it again, getting more and more storage, more and more storage. At some point, you already paying hundreds, thousands of dollars per server, and you again need more, but there are no server to fit all of your data. And then you have to go sharding. And sharding in relational databases or non-relational as well is extremely hard. What differs Cassandra? Cassandra is big data ready. What does that mean? It means what it can handle any amounts of data. You didn't misheard that. Apple stores in Cassandra hundreds petabytes. Can you imagine such a huge database in MySQL? It won't work. That's why Cassandra distributes data in the partition from the very beginning. It's required to be able to scale for data of any size.
Yeah, good point. Well said. Thank you. Okay, so this is why a table is distributed from the start. So it is ready to host a very large number of rows, a very huge amount of data, without worrying about later problems, because it starts distributed. And how is partitioning working? So we say that the partition key in this table, in the sample table, is the country. So what happens behind the scenes is that the value of country, you see on the left, you see Australia, Canada, Germany. Well, these are values. In this case, they are two-letter text values. They are made within, there is a function called partitioner that makes this value into numbers. Now, in this example, numbers are 0 to 100. In reality, it is a very larger amount. I think it's 2 to the 64 or something like that. Anyway, the partitioner transforms the values in the partition key into numbers, and every node is assigned a range of these, what is called a token range. So you see in this example, we have 4 nodes, and the total range is 1 to 100. It's not like that in reality, but that's to a simplified form. And the first node will take care of numbers of values of token 1 to 25, the second node 26 to 50, and so on. So within the belly of Cassandra, whatever the column in the partition key, they are always made into numbers, and the number will determine what is the node responsible for this piece of data. So you see, the fact that several rows with the same partition key will always end in the same node is guaranteed by this process, because several rows with the same Germany, so Berlin and Nuremberg in the example, will have the same value of the token, and they will be guaranteed to end both in the second node in this example. Now, the partitioner is a function, so every node is able to do that. And indeed, a crucial point is that every node is aware of the shape of the topology of the cluster. So every piece of data that has to be written or retrieved, every node is able by itself to compute what is the right node to store the data. And this is the principle that guarantees the constant time, the constant access time, even if the cluster is very large, even if the ring is very big. Every node by itself is able to directly drive the data to the right place, without having to speak to any coordinator of any kind. So these are the token ranges, and let's pretend it's the full token range is the full tokens range from 1 to 100, and we have a 4-node data center. So you see each node is responsible for 25 values of the token. Now let's say my application is becoming more and more popular. I need to host more and more data, and what happens? We told you already that you can scale horizontally, so we add a node. Surprise. The full range, instead of being divided by 4, now is divided by 5, and every node is responsible for 20 values of token. And this is the typical scale-out situation. I see a question, is auto-scaling available? Well, the nice thing is that the redistribution of data happens automatically. So whenever you add a node, a process of data streaming takes place. And in a little while, well, it depends on the size of the data, but eventually the data will be redistributed according to the new token range assignments. Now, there are two observations to be made in this. One is that there is no downtime. So there is no moment during this process where your application has problems. So the whole process happens, and in the meantime, the database will continue being completely available, and reads and writes will be able to be done. The second point is that the way partitioning is made guarantees that the amount of data that has to be streamed is the least possible amount. And this is due to a property of the partitioner that is the consistent hashing property. So the way partitioning is done guarantees that the amount of the number of rows that have to be moved from one node to the other is as little as it can be. Now, well, in many cases, applications have to have growing data demands, but there might be also cases where this is the opposite. So let's say Christmas season is over, or Black Friday is over, and my very big need for large database is over. So I want to scale down for some reason. I want to scale in. So I want to go back to having fewer nodes. The good thing is that this is also happening automatically. And again, there is no downtime, and everything works as any administrator would like it to be. And so Cassandra is able to take care mostly automatically of these processes. Then again, there is a layer of manual management that might enter in some cases. So it's not a black box kind of thing, but most of the boring operation can be left to happen automatically.
Sorry,
Okay. Yes,
please get back to the previous slide.
Yeah.
So take a look. There are a lot of questions about how it differs from sharding, or how do I redistribute data after scaling out or scaling in. So let us phrase that one more time. Partitioning is totally automated. You just add new server to the cluster, and Cassandra will recalculate token ranges. Cassandra will transfer data. Cassandra will enable new server when data transfer is finished. And that's a cluster job, not yours. It's totally automated. On the other side, then you decommission a node, Cassandra will recalculate token ranges, Cassandra will stream data, Cassandra will then decommission those nodes, and you are good. And it's all totally automated. With sharding, you very often have to change your application at application layer in order to support new shards. With Cassandra, you don't need it. You still work it with a single database. So sharding is manual, slow, and painful. Partitioning is totally automated, and cluster makes your work for you. I love it. I'm a lazy engineer. I prefer cluster to do my job.
Yeah. So there is a question, are only 100 tokens issued per cluster? No, actually, no. The 100 is just an illustrative example. The real numbers are 2 to the 64, I think. Anyway, it's a huge number. So this is the real range of tokens. It's a very huge number. And yeah, so that's able to deal with a very, very huge number of partitions or token values, which in this sense is the same. Indeed, you can have a very large number of partitions in a Cassandra table, and you can hardly hit a problem there. Okay. So let's go forward. Now, all nice, all good when it comes to data distribution, but obviously we are very much responsible people when it comes to data, and we want to make sure data is properly replicated, because you have to plan for failure. So there is a concept called replication factor, and that's a number, a low number usually, and it just says how many nodes will host a given piece of data. So in the example you see so far, every partition, every part of the table, every single value of the country was on a single node, but that's hardly a good setup in production, because you are obviously very much in danger if a node goes down for some reason. Indeed, it's good to have the data over several nodes. So you have this replication factor. Now, let's say I have replication factor of 1. That means that every partition will go to one node, as in the example we saw so far. So there is this block, this USA partition in the table of the count of the city population, and this is just on this purple node, and that's it. Of course, that's not something we would recommend in production, again, because a machine can fail, you can have any kind of problem, network connectivity, whatever. So we can consider replication factor 2. That means that every partition, in particular, for example, this USA partition, will be hosted by 2 different nodes, as you see here now. That's good, that's better. And you can also increase to replication factor 3, which more or less is, let's say, in almost all setups is the recommended choice. So if you don't know better, you should assume in production replication factor has to be 3. That's it. And there is hardly a situation where you would go beyond 3, because then you have less and less advantage and more cost, I would say, in storage. So if you have replication factor 3, except for very strange setups, that's good enough for production. So what this means is that every piece of data is in 3 different nodes, but that's not the same as saying that the whole table is on all nodes. Because again, as Alex remarked, you can have a very huge database, and that would not fit on any individual node. It is just to say that there might be USA on these 3 nodes, and there might be Germany on 3 nodes partially overlapping, and so on. So there is no single node having the whole data, but still you are not losing even a single row if a node is temporarily unavailable, and that's good. Okay, so replication factor 3, let's say, is the recommended choice. And then we will then fix RF to 3. So let's see what happens when, for example, some data needs to be written. Because now we have distributed data, we have 3 different nodes that will be responsible for, let's say, the USA part of the table. So let's see what happens when your application has to write these 2 rows about USA to the cluster. So the application, for some reason, reaches node 17 here. And the node number 17, which means 17 stands for the token range corresponding to this node, by the way. So what comes to the node is USA, but the node by itself, as any other, is able to apply the partitioner function and to turn USA into the number 59. Again, these are fake numbers. These are small-scale numbers to make the explanation easier. But anyway, the node number 17 says, oh, I have some data that belongs to token 59. So I have to carry over these pieces of data, these new rows to be inserted. I have to carry them over to this, and this node. And this is what we mentioned earlier, because now node 17 is acting as query coordinator for this write. Even though, and that's entirely possible, node 17 is not even hosting, is not even storing the data itself, but that's not a problem. It is just acting as coordinator, and it will distribute the rows to write to the 3 nodes that have it. So what happens is that this data USA, which correspond to 59, they go through the node 17, and they have to go there and there and there. So the other 3 nodes, and this is what happens. The orange node acting as coordinator will send the rows to write to the other 3 nodes, which will then store them permanently in their own file system in a particular way. And there it is. So this is how a write happens in this replicated setup. Now, let's see that for some reason, let's assume that for some reason, one of the 3 target nodes is temporarily unavailable. It is broken, it is rebooting, whatever. Catches fire, you never know. Okay, so first point is that generally speaking, the database is still working because of replication. But then what happens with your write? Well, the nice thing is that if the coordinator, if the orange node notices that one of the 3 target nodes is not answering, is not able to acknowledging the write, it will store what is called a hint locally. So node 17 knows that it hasn't reached one of the 3 target nodes, and it will just store the hint. Later, the blue node comes back again, and it will receive the hint. So as soon as it becomes available, it will receive hints by other nodes, which will notice that it has become available again. So it will be able to realign its data with the write. So at the end, you will have consistency again. And this is more or less the hint mechanism at play. So, okay, there might be cases where the hint are not enough for that. So let's say a node might be down for days and days for some reason, and then that will call for some kind of manual repair mechanism, which anyway is a good practice to do periodically. But let's say in ordinary temporary downtimes, they are automatically handled by Cassandra itself. Now, before going on, Alex, do you want to bring our attention to some particular questions, something that pops up in the chat?
No, I believe all questions are answered.
Very good.
And there is not something I would.
Okay.
There is not something I would highlight at the moment.
Okay, so let's go on. Now, we've been speaking about replication, and replication solves a lot of problems. So basically makes my system more robust, more resilient, but it has some downsides, let's say. Now, I am showing a slide about the CAP theorem or CAP theorem or Brewer's theorem. And that was mentioned in the chat. I've seen a few passing references to the CAP theorem in the chat earlier. So some of you at least know what it is about. And let's briefly speak about the CAP theorem because it's important. So every distributed system, unfortunately, has to obey this theorem because this is a theorem, like a mathematical theorem. It is a limitation, but it is not a limitation due to how the database is built, how the distributed system is engineered. Rather, it is an intrinsic mathematical limitation of this world, of this universe. The point is that there are 3 features that I would really much like to have in a distributed system all at once, ideally, but I can't, and you can't, nobody can, because they sort of exclude each other. Now, let's have a closer look. So I guess all of you would like your database to be consistent, which means that every client reading the data will get the same values, regardless of which client, and also during concurrent writes. So I would like every client to get back the same values, basically. That is very much a desired thing, right? But I also would like my system to be available, so to be always possible to query it anytime. but I also want my system to be able to work even in the case of network failures. And that's a tricky point, because first point is that sooner or later your network will have some problem. Your nodes will have some problem speaking to each other. Even in the best hardware setup, at some point there will be some network failures. And I want my system to be able to work even in that case. Because there is a very huge risk, and the worst that can happen in a distributed system is that somehow there is a network disruption and two parts of the system think they are the whole system and they start diverging. Let's say my database is split because the network is temporarily broken, and the two parts of the database, each one thinks it is the whole database, and it starts, reading and writing and accepting reads and modifications. So let's think of the database behind a bank account. It's very much a danger, right? If one half of the database is writing transactions and changing my bank account values, and the other half is doing differently, so that's not even a database anymore. It's a split brain situation, and that's something that I have to avoid at all costs. Indeed, partition tolerance, so the ability to work even in the case of network failures, of these three properties is the one that I cannot avoid. I mean, any reasonable system has to guarantee partition tolerance. So basically, the CAP theorem says I can have two of those at a time. So I can design my system to guarantee two of those at most. Now, I don't want to have split brain problems by no way. So basically, the choice is between having CP or AP. So I'm forced to make a choice. Now, every database, NoSQL or relational anyway, they sort of take their choice. And they might be designed to be CP, they might be designed to be AP. So it depends on the use case they are more poised to support. The cool thing is Cassandra. Many say that Cassandra is AP mostly because it favors availability over consistency, basically. But that's not entirely true. And I know that this point is very dear to Alex. He's smiling.
Right.
Actually, the cool thing is that you can tune Cassandra. You can tune Cassandra to be more on the AP, so available side of things, or the CP. So you can ask Cassandra to be more strongly consistent, maybe sacrificing a bit of availability, or you can ask Cassandra to be available, maybe sacrificing the strong requirement of consistency. And the cool thing is that this happens per query. So for every single query, you can ask the system to basically choose between availability and consistency, or something in between. And maybe we can move forward and have a look at maybe this is represented within the Cassandra, the interaction with Cassandra. This is represented by the consistency level, which is the concept of consistency level is a setting that is every query you run on Cassandra comes with a consistency level. And basically that means how many nodes I want to acknowledge the operation before the coordinator sends back an OK to the application. So I want to write a piece of data from outside, let's say from my application, from my drivers, whatever. I can ask Cassandra, dear Cassandra, I want you to make sure all involved nodes have done this right before you give me your OK back. Or the opposite is, I just want you to make sure a single node has given me an OK, and then I will take, I don't care about the rest. So The consistency levels range from any, which is very much discouraged, except for very strange cases. Then there's 1, local 1, 2, 3, quorum, local quorum, all the way to all. So usually the right choices are somehow in the middle, but let's maybe have a closer look. What are these values? Those basically mean how many nodes will need to send the acknowledgement back to the coordinator before the coordinator in turn gives an OK back to whoever issued the query, the write or the read. Okay, so these are the consistency levels. But if it comes to if there are many data centers, the situation gets even more complicated. But let's start with consistency level 1. And let's say this is a write operation. Maybe an example might help explaining this. The client wants to write a piece of data. We have replication factor 3, so there are actually 3 nodes involved. 3 nodes will have to end up with the write in their file system, ultimately. So the client speaks to a coordinator. The coordinator knows that there are 3 nodes involved, and it will send the write to all 3 in any case. But the point is that as soon as one of them sends an OK back to the coordinator, then the coordinator tells to the client, OK, I'm done.
Yep, I would better say as soon as this confirmation acknowledgement is received, because acknowledgement can be sent but never received,
right?
and lost because of a network. Yep.
Yes. So yes, as soon as the coordinator receives a single acknowledgement, that's the meaning of 1. Then the client, then it sends to the client, OK, I'm done. But that's very important. That is not the same as saying that only one node will get the write, because the point is that the coordinator will send the write to all 3 nodes involved anyway. The point is that 2 of them will be done asynchronously, and only one of them will be synchronous with the whole write operation. So consistency level quorum just means more than half of the replication factor. So in this case, 2 out of 3. Consistency level quorum means that the coordinator will wait for at least 2 acknowledgements to come back to the coordinator, and then it will tell the client, OK, your write has succeeded. And then consistency level all, you can imagine, the coordinator will wait for all nodes, all 3 nodes, to send back the acknowledgement before it speaks to the client. Now, in some cases, all is recommended, but in many cases, that's probably too much. And you might think, very good, let's use all the time. But yeah, remember the CAP theorem. So if you ask consistency level all, you have to be aware that you are moving the needle all the way to the consistency part of the theorem, and you are sacrificing basically availability. Because think what happens if even a single node of your cluster is temporarily down, then no write will ever succeed. And that's probably not what you want. So be careful, because the CAP theorem cannot be avoided. What you can do is to plan your consistency levels according to your needs, query by query, which is pretty much a powerful thing to do for you. Okay, so that being said, let me very quickly mention one thing. In most workloads, what you want to do probably is to have what is called immediate consistency. So you want a guarantee that if you do a write and then you do a read, you will never get obsolete data, stale data in the read. And to get that, there are various ways. The best way is, let's say, usually the best way is to have quorum when writing and quorum when reading. Because if you think about that, if you have quorum and quorum, you have a guarantee that the 2 majority of nodes in reading and writing will overlap. And since there is also a timestamp comparison, you will never get stale data in this way if you read after writing, basically. with a minimal overhead on the cluster, much lower than if you had all, for example. So immediate consistency is quorum. Sorry, yes, Alex?
You sorry me for interrupting, but we have a great question actually by Varun Nayak. Can application decide certain table on availability and certain tables and consistency? Short answer is yes, but that's actually even better. You can, to control consistency, you have two buttons, two levers, two knobs, replication factor and consistency level. Replication factor is defined per key space, and consistency level is decided per query. So you can execute queries to the very same table at a very different level of consistency level requirements, and that is amazing.
Yeah, absolutely. That's very cool and gives you pretty much a granularity, a fine-grained way of controlling your application, because actually the typical application has different needs within it. So there might be writes that are very much secondary, so to speak, like writing a log entry, and other that are more critical, and have been able to tune individually. That makes absolutely sense. Yes, you can choose consistency by individual query. Okay.
One more point. I believe you highlighted that, but Animesh McG asked a very good question also. What happens if there is a discrepancy in data being received from nodes? How to choose what to send in read cases? Is it explained?
Oh, I just mentioned that there is a timestamp comparison and that there are digest sent along the way. So maybe that would lead a bit too much. I don't know. Do you want to spend a few words on that?
Yes, please. Could you get to the previous slide?
Let me go to the relevant slide.
Right.
This one, maybe it's good enough.
Yeah. Good. So the point is, when we get answers, let's say we make a read request with consistency level quorum at replication factor 3. It means what we will wait for two pieces of data, two exemplars of our replicas before we return answer to the client. As you see on the screen right now, if we get the same data, that means, we return this data. If one of the exemplars is too old and outdated and stale and not correct, outdated, wrong, when new piece of data, the newest piece of data will be returned, the newest version will be returned to the client, and meanwhile, query coordinator will enable the second layer of defense. Cassandra has multi-layered defense from inconsistency. First layer was hinted handoffs, and second layer is a read repair. Then Cassandra, during the read, notices what there is an inconsistency in data. It starts a repair for the failed segment. And so the node what returned stale data will immediately be recovered into the consistent state, and it's totally automated again. You don't have to worry about that.
Yeah. Actually, there are a few mechanisms to ensure consistency. Some background running hidden repair mechanisms, automatic, manual, initiated by read queries. A lot of things happen behind the scenes to ensure consistent data all the time. So, but we will not highlight them all now, and I suggest we move over. So another observation is that data is actually, we said that already. Data in Cassandra is made to be distributed not only within a ring, a cluster, but also within different data centers, between different data centers. So here you see I have a whole database made by data centers around the world, or maybe on different cloud providers, or both things at the same time. So how does that happen? Obviously, within a data center, you might hope to have very low latency, but probably you don't want your query to need to do a round trip of half the world before your client gets an answer. So, just to mention, this is very much possible and it works like that. But to handle multi-data center situations, there are consistency levels that are specific to limit your query to a single data center, or not in some cases, but you know what you're going, so you know what you're facing, so higher latencies, that there might be cases. Another point of distribution of data is that when you create key spaces, which are grouping of tables, you define replication factor per data center. So you might create your key space with a replication factor that is 0 in America and 0 in Asia and 3 in Europe. And there you have your tables that are GDPR compliant, because by definition, by the way you created the key space, tables that you put there will only live in Europe, and you are compliant. So this is how you control, say, data governance related things. Okay, so we've been looking a bit at how Cassandra works internally, how its architecture allows the astonishing powers it has. So very briefly, a few remarks on the use cases that are typically good fits for Cassandra. Cassandra is very much scalable, so it can support very huge amounts of data and very high volume of reads and writes, which makes it a good fit for several types of applications. So you have heavy writes, heavy reads. That means that application that produced a lot of data, IoT, log analytics, event streaming, or any kind of time series, indeed, they are very good use cases for Cassandra. By the way, Cassandra, when it comes to time series, has specific optimization that can be enabled for tables that when you know that they are written in a time or ordered way. But we don't go much in detail today. Then Cassandra, if properly configured, is very highly available, so it might be a very good candidate for mission-critical cases. When you have to guarantee that the database is always on, always available, that you will never lose data, even if you have a small database, but that is very much critical that it will never be down. So, for example, market data, pricing, inventory, and similar application, medical critical data, or stuff like that. Cassandra is distributed. I hope we convinced you that it is distributed and very well at that, which means that if you have to be close to the customer everywhere in the world, that's a good fit. If you have to support mobile workloads, that's good. And as I just mentioned in a few slides ago, if you have to obey compliance requirements, also, that's very good application. So any kind of things related to banking, retail, customer experience, and similar, and actually any application where you want to give low latency all in the world, everywhere in the world, is a good fit for Cassandra in a sense, thanks to the way it takes seriously the distribution of data. Last but not least, Cassandra is good at cloud native applications. Indeed, it is able to support modern cloud applications in several ways. It is very easy to build microservice-based architectures on top of it. That's one thing. Not only that, but Cassandra itself is so it is a good fit for Kubernetes. Indeed, there is a way to deploy Cassandra within Kubernetes that is called Cassandra, and it is a very cool open source initiative, and that makes for all the cool cloud native things of today. So I suggest you to have a look at Cassandra if you are into Kubernetes. Now, I see a question, is SQL the only tool to access the cluster? Well, no. No, in various ways. One is that you have drivers for most programming languages. So you can, today we are using SQL, but when you write your application, you will probably use drivers, which just will expose access to Cassandra programmatically. There's other answers here, because on top of Cassandra, there is a layer that is also an open source project called Stargate, and this is able to this builds a set of additional API layer on top of Cassandra, which makes it possible to access Cassandra data in a REST way, in a document API way, gRPC, GraphQL, you name it. So there are actually very many ways to access and input-output data in Cassandra. Okay. So let's have a quick look at the rest of this part. So let's have a look at how data is structured and how you design your tables when you have an application in mind, which is very much important. Okay, so what is the fundamental unit of data in Cassandra is a cell. So we've been already speaking of tables, and you can imagine what a cell is. It is an intersection of a row and a column, and it can store data. Let's say a string, number, or other double, time, date, timestamp, UUID. So there are several kinds of data types that Cassandra supports. When you have cell one by the other, you will have a row, and the row is just a slice of your table. So a number, a name, a family name, and a department, let's say. Several rows together will form a partition. So in Cassandra, we started by showing you that you think of your table as split into partitions, and the partitions are defined by it was the country name. So Canada was all going to a node. So a partition is just a group of rows that share the same values for the column that is the partition key. So in this case, department. All three rows here share the same value for department, and they will form a partition. And they will always be stored together. The storage is per row. So every row will go to, so rows are stored together, the whole row, and many rows are stored together if they have the same value for the partition key. And yes, partition key can be composite, so it can be made by several columns. And in some cases, it is like that. Okay, so the outer layer above partitions is the whole table. The table is made by partition. And this is the general picture. So you have this concept called key space, which is a grouping of tables. Within a key space, you have tables, and every table is basically like a spreadsheet. You can think of it as a spreadsheet, so columns times rows, but internally it's very important to think of a table as split into partition, and every partition is guaranteed to be all together, but different partitions might be on different nodes. And that's important because that's not a detail, a technical detail that you can forget and leave to the administrators. But also as a developer, as a data architect, whatever, you have to take that into account, because when you model your data, your tables, when you design your tables, you have to remember that different partition will be on different nodes, and you will never want to do a query that has to ask data from several partitions at once, because that would mean having to speak to several nodes in a query, and that's very slow in general. If your cluster is big, that's very slow. So you can already guess from here that if you design your data, your tables in the right way, you will design tables so that your queries will be always directed to a single node. And that's the best, that's the biggest point in modeling your data. Okay, so this is the syntax. We already mentioned SQL. SQL is the Cassandra query language, and it looks a bit like SQL, but don't be fooled, because below that there is a whole different architecture. I hope by now you are convinced of that. But this is how we create a table. So create table name, and then column type, column data type, column data type, and at the end, primary key. Now, this primary key at the end is the most important. So it's the most, it's the part I want to describe more in detail. So this is how we are creating a table that will contain user information. One of the columns is the city. And you see there is this funny double parenthesis syntax here. So when you create a table, you have to define what is the primary key. And a part of the primary key is the partition key, but let's go forward. So, okay. We will come to this statement later. So okay, this is something I mentioned quickly, that when you create a key space, you define a replication factor per data center. So you can have it replicated 3 times in a data center, 5 times in another one, and 0 times in another one. That's something that we mentioned, speaking of GDPR and similar data compliance. But let's go back to the table creation. So very much similar to what happens in a relational database, you have something called primary key, which is a selection of columns of your table, and they are chosen to guarantee unicity of the rows. So they primary key value, the values of the primary key have to differ row by row. You cannot have 2 rows with the same values for the primary key. And which one to choose? Well, it depends on your table. So in particular, when you define the primary key, in general, you specify a subset of the columns that is the partition key. So look at this example. Primary key is city, last name, first name, email, which means that every row is a unique combination of these 4 values. So there cannot be 2 rows with the same city, same name, and same email. But in particular, city here is the partition key. It means that primary key is a logical way of describing the data, but partition key is a way, let me say, physical, is a way to define where physically the data will go, which node will host the data. And since the partition key is city, now we are saying all the rows from Ottawa will go to the same partition, will be on the same node. All the rows from New York will go to the same partition, same node. And that's important, again, because we want the queries to be just going to a single node. Okay, so the partition key, I just explained that. And so the partition key identifies the partition, and there has to be. You cannot create a table without a partition key. Okay, so in general, you have columns that are part of the primary key, but they are not partition key. That means that your partition will have several rows, potentially, and they will have the same partition key, same city, for example, but different name and email. That's okay, and they are called, so these additional columns that are not in the partition key, but they still define uniqueness, are called clustering columns. And they actually are used to decide the internal sorting, the ordering of the rows within the partition. Now, there are choices that you should avoid because they will not work. So look at this example. If you have a primary key that is city, last name, first name, that's not good, because if you think about it, what can happen? So I want these to define uniqueness of rows. But if I have city, last name, and first name, don't you think there might be more than one John Smith in New York? Probably there is. Probably there are many of them. So that's not enough. If I want to guarantee uniqueness, that's not good, because I might have different users who would have the same values for all 3. So the right solution is to add another field in the primary key to make this a good choice of a primary key. So different John Smiths will have different email, at least. In a different way, this video ID, comment ID is not an ideal choice of the primary key, but for a different reason. That's because, let's say we are building a YouTube-like of application. So we want to keep comments on videos in a table, but the ID is a random looking string. So since the clustering columns define sorting the comments by their ID doesn't make much sense. So it's better to add creation date, for example, in the primary key. So the sorting within the partition will be useful, will make sense for us in our application. Okay, so that's about partitioning. There are some pitfalls to be aware of. So remember that when you choose partitioning, you are choosing which rows are going to be together in the same node. So you have to make sure your partitioning keeps together rows that you want to retrieve together. So your query will go to a single node straight, and you will have fast queries. On the other hand, okay, so let's see. This is an example. You want to store together what you are going to retrieve together. So in this YouTube-like application, look at the first example. The primary key is video ID created at comment ID, all good, all nice. And in particular, if I create the table in this way, my first column is the video ID. In particular, the partition key is video ID. That means that all comments for a given video will be together in the same partition. And that's good because I can get all comments for a given video in a single query, in a single select. And that's probably what is needed for my application. While if I choose to partition this same table by comment ID, that hardly makes sense because I will be having a hard time retrieving all comments for a given video. And that will really not work much. On the other hand, I have to make sure I'm not creating partitions that are too big because that might not work very well. So even though look at the same, so the first example here, video ID created at comment ID, yes, might work, and it will work. It's good because it groups together all comments for a given video. And look at the second example. That might theoretically even work, but I would have a bazillion comments in the same partition because they are just grouped by country. And there are a lot of them, and I hardly need all of them at once. So that's really not a good choice of partitioning. And it might expose me to the risk of having a huge partition. Well, that's not the only point. Maybe I can skip this point. Well, okay, I can. It's a bit late, so maybe we skip this point. Let's just mention that a hidden danger is to have partition that initially work well, but then they pile up more and more rows, and at some point they become too large. So there are solutions to this. Maybe very quickly, I can invent synthetic fields and add them to the partition key. So to have to divide my partition in blocks that are guaranteed not to grow indefinitely. That's called bucketing, but I have to skip a bit on that. Another danger is to avoid hot partitions. So look at these examples. I'm grouping items. Maybe it's still the video comments in this YouTube application. I can group them by user ID for some reason that probably works. I can group them by country, but that's a very much a danger because there might be a lot of activity in a partition, let's say the India or the US partition, and not much activity in the Vatican or the Belize partition, which are smaller countries. So I'm really not balancing the load on various partitions, so on various nodes, which means that I will be not using the power of all nodes. Basically, even if I have a lot of nodes, there will still be a single node hosting the India partition, which is probably having a lot of activity. And that's what is called a hot partition. I have a lot of read and writes going to a single node, the node containing the partition for India. And even if I have a lot of machines, that's really not going to be spread. So the load is not well balanced. And that probably is a hint that I have to rethink my data model.
Wait a second. I wanted to explain a very important thing. Those slides have a slide of the year award for a reason.
Yeah.
And let me explain why exactly. The point is, just Aldrin Einstein asked it a great question. If I have a partition and later add a bucketing, what happens to my old data? We might have a slide about that because it's very important. Once your table is created and your primary key for this table is decided, so partition key and clustering columns, you cannot change any parts of a primary key. And
Yeah.
if you find out what your partitioning was wrong, you will have to create a new table and you will have to migrate all the data to a new table. And that's quite a lot of work. That's why we always enforce the idea what it's very, very, very important to think ahead of your data model and think ahead of your partitioning. And that's why we call those slides the most important the slides of the year 2021 for you. This year is almost over, and I doubt you will see any more important slides in this year.
No, this will
It's
be the
hard to beat
winner.
those going to be the
Yeah.
winners. So, yes, migration is going to be painful, so you have to really, really thoroughly think ahead about your partitioning and data model. And data model is something what Stefano will explain in the next slides.
Yeah. So there is a reason why you can't change the partitioning once the table is created. The reason is that you might have a cluster made by 200,000 nodes, several petabytes of data. And if Cassandra let you change the partition, that means that every time this happens, you can imagine how many pieces of data have to go around, and your cluster will probably be just, on its knees. It will be absolutely overwhelmed. So the choice that Cassandra takes to make it possible to afford huge amounts of data is that you have to think carefully of your data model before you create the tables, and then you stick with it. That's a bit of an extreme choice, but it is the price to pay to be able to reach very huge amounts of data and the wonderful performance on that. So let's create a table. Alex, it's time for a bit of practice.
Let's create the table. I love it.
So
Sounds
you
good
will
to me.
now jump to your
Okay,
screen
we will
and
jump to my screen and we will answer. So give me a second then. All right. Okay. So, ladies and gentlemen, we get to the second part of our lab. As I said already, you can do it with me right now on or complete it later. For the homework and for the page, it doesn't matter. Just don't forget to make a screenshot of the last screen of the last step, which comes in the next part of the lab, actually, not in this one. So we created our Cassandra database, and now we want to work with the tables first. At first, we will navigate to SQL Console and log into the database. In this case, that's very easy. You basically just click to SQL Console, and mostly probably you're already able to operate. You can type a help command. You can type a command describe key spaces, and you will be good. Now, our next step is going to be we want to ask to describe our key space. So my key space, I type a describe command, key space, Cassandra, the key space we created for this class. And we see this command, the description of your key space. Create key space Cassandra with replication, network topology strategy, Europe Central 1, free, and durable writes true. What that's all mean? That's what the command used during the creation of a key space for us. It uses network topology strategy for the replication. There are two replication strategies, simple and network. And simple is good for your laptop and bad for anything else. And network topology strategy is for real production deployments because it keeps control of your replicas. So replicas will be located as far away from each other as possible in the single server racks, in the different availability zones in different server racks to ensure they not fail together. We're far away from each other. Then Europe Central 1 is the data center. We use it to deploy this one, and it has replication factor 3 and durable writes true, which is out of scope for this workshop. So if you want to know what the durable writes mean, you have to go to the academy.datastax.com and take a course of Apache Cassandra. That's the way how you get ready for your certification. Anyway, now our next exercise is going to be Describe key spaces, we did that already, and we see what we have, some key spaces. Most of them are system, so they belong and managed to Cassandra. And now we are going to work with a key space we created for this exercise. And that's going to be very simple. I just type the command use Cassandra, and I can use tab to autofill the end of a line. So as you see, I'm using now Cassandra. Good. That's key space. I will create my tables. Now we are going to create a users table. And this, at this point, we can execute a command to create users table. We will just copy paste this simple table, create table of not exist users, email, name, password, user ID. The first three lines will be type text, and user ID will be type UUID, universally unique identifier. Primary key will be email. And now you can guess. Take a look. If I execute an insert statement in this table and insert three different users with three different emails, how many partitions I will have in this table? Please type your answer in the YouTube chat. Meanwhile, I'm executing this query. How many partitions this table will have if I execute three different inserts with three different users' emails and three different users? And meanwhile, Rakhavan asks, is keyspace similar to a schema? Yes, keyspace is similar to Postgres schema. And Sajal, Animesh, and already others, Rakhavan are giving the right answer. Three different emails make three different partitions. Yeah, as many as the users. Correct, correct, correct. Thank you so much. Looks like you did a good job following us at this workshop. That makes us happy. Well done. Good. Okay, so we just created a table. It has partition key. It doesn't have clustering columns, which is totally fine. Now let's work and let's proceed. We will ask to describe tables. So we do it with describe tables command. And I see what I have, only one table, users. Now I can ask to describe table users. And you see the command which SQL prints output is much longer than one what I've pasted. Actually, I told you already there are 1,000 of different knobs and buttons and levers, how you can configure your Cassandra. But in this case, we use actually, we use it only the required one. When we created a table, we define it a primary key. All additional settings are optional and defined to just follow the default. By the way, if there are someone who works with plain open source Apache Cassandra, maybe you have noticed the difference. As you see, AstroDB uses unified compaction strategy. Although modern Cassandra version 4 doesn't use it, it's not yet merged into the trunk. So in this case, AstroDB is a little bit ahead of Apache Cassandra from the features, but we don't speak about unified compaction strategy today. Anyway, you can learn about that on our next events. So we have our table described. Now we have users, but that's not enough. Let us create a few more tables. We will have two new tables, posts by user and posts by room. Stefano, would you explain us why do we need two different tables for posts?
Yeah, well, I can explain that in one word now, and then it will be a bit more in the data modeling part.
As you wish.
Yeah, very quickly. The point is that you might remember that I stressed a few times that you have to design your table so that the partitioning will support the query you want to do. So in particular, you always want to query a single partition at a time. So let's say your application needs two different ways to get comments to get posts. One is by user. I want all posts by user X, and the other is by room. So because this is a chat room, this is a chat application with several rooms, I want all posts that have been written on room X by anyone. So these are two different and very much independent way of retrieving posts. And the right thing to do with Cassandra is to create two tables with the same rows, grouped differently. That is to say, partitioned differently. And that's why, in some cases, the correct way to approach data model is I create two tables which are basically the same, except different partitioning. And then it will be my job as an application, as an API or whatever, to write to them at once, to keep them aligned. That's the quickest answer I can come with.
Mm-hmm. And I will say just it's in a little bit simpler manner. Don't forget our data is distributed. That helps us to scale out, but makes harder to get the data because we have multiple servers and we need to know which particular server to ask. If we ask all the server together, it's called full cluster scan, and that's a very bad idea. It's not going to work fast. So when doing select statements, we have always to specify partition key. And if we are looking for messages by user, we know user ID, but we don't know the rooms he wrote to. So we can search by user ID, but we cannot search by room. And if we search for all the messages within a room, like this chat on the YouTube, well, then we know the chat ID, but we do not know user IDs. And therefore, we have to duplicate data here. And now, question by Aldrin Einstein, want we duplicate data? And answer is yes, wait for it. We explain it on the next slides. But let's call it denormalization. So we created those tables. And let's take a look. Now I can describe tables again. Describe tables. And oops, I will see. Yes, I have my tables users, posts by room, posts by user. Well, oops, wrong tab. When we go. We just created multiple tables. And now we proceed with the next slides before we go with the write-read operations. Okay? Let me switch the screen. Hey, Stefana, are you ready?
Yes, I'm ready. I was trying to give a few answers in the chat, but I'm here.
I will proceed. I will proceed. Don't worry.
No, I'm ready to jump to the data modeling part.
Yes, please.
Yes.
Now, please pay your full attention. If you want to fail with Cassandra, data modeling done wrong is the best way to fail with Cassandra at ease, with a style. No, with no style, it's boring, and that's typical. So don't do that. Be better than that.
So please pay attention because Cassandra is powerful and it can give you very high performance, but you need to get data model right because as with many powerful things, it requires some responsibility. So let's see how you model your data for an application with Cassandra. First thing is there is a concept called normalization that is a very illustrious and celebrated idea in designing databases, and it has been in place for more than 50 years, and it is the base of relational databases. So you have relations. Basically, you never duplicate any piece of data in your database. Every information is there only in one place, and you have ways with IDs, basically, and references, and what kind of identifiers. You have a way to embed relations between tables in a way that avoids every duplication of data. And this is normalization. Very good, very nice, conceptually very cool, actually. But as the amount of data grows, that starts to show its practical limitations because you start having a lot of joins, a lot of complicated queries, and the performance is suffering. You can have queries that take a lot of time to execute. And in today's world, sometimes you just cannot afford that. It's as easy as that. So there is a counter idea of denormalization, which is one of the basic ideas that is shared by most of the NoSQL databases. And it basically says, oh, let's forget about normalization, which is nice and mathematically very elegant, but we want to go fast. So we just take the data duplication as an idea and we promote it as the founding idea. So no problem if I am duplicating a piece of information. No problem, as you see in this sample table, department. So there are two different employees in engineering. Well, I just write engineering twice, no problem. There is not a different table engineering departments and then an ID here. I just duplicate engineering. So that's risky. Some of you who with a relational background might say that's risky. Yes, in a sense. But the point is that when I then want to retrieve employees, I don't need any join. So that's, in a nutshell, that's the idea. I don't need any join because I sort of resolved the joins at writing time. So when I read, I just read fast from a single table all the time. I would like to spend more time on this point, but probably we are a bit, we are a bit late. So
Yeah, but anyway,
maybe,
I will require a second because it's a very important point.
yes,
It's a
yes,
point that
please.
scares many. We were told for many, many years in the universities, on the courses and whatever, what normalization is great and denormalization is wrong. And that's not like that. Those are tools. Those are good as long as you control them. Denormalization is not like the dark side of a force, which is bad by default. We don't live in a Star Wars movie. We live in a real life. Take a look. When you work with a normalization, it's great because you can, with one single write, update all the data because data is normalized. You don't have redundancy. You don't have redundant copies of your data. One single write, you get everything. But when you do select, you have to go with joins, and joins have two problems. First, they are slow, and second, they are double slow if your data is spread across hundreds of servers. And finally, the killer feature, what kills joins if you need a performance over big data. Idea is very simple. You can execute joins only consequentially, one by one by one. If you have 3, 4, 5 join statements, if your statement in your select query, you are going to have the executed one first, only when second, only when third, only when fourth, only when fifth. You cannot do them in parallel. That's why they cannot be slow by design. They cannot be fast by design, and that get even worse on a big data on a distributed system. On the quite opposite, denormalization requires a redundancy of your data, spread it over multiple tables. So now you have to do multiple writes when you update the data. But when you do a read, you have to do only one single read. With no joins, you get all the data at once with a very simple query. And now take a look. That looks like a compromise solution, but the point is, Cassandra has extremely good write performance, very good read performance as well, but it has incredible write performance and ability to scale for writes. And now notice the trick. I cannot execute 5 joins at once. I have to do it one by one by one. But I can execute 5 write at once in parallel. And as a result, denormalization is significantly faster. And we are fighting for performance so our customers get their answers immediately.
Yeah. Okay. Okay, I wrote an answer about pagination and reading many, many rows, which...
Yeah, pagination basically works the same. You have all the limit of set options, so pagination works exactly the same way.
Yeah, but still, if the question is how to read a lot of rows, and if that implies to read like all the table, that's probably not the workload for Cassandra itself. You might want to use OLAP specific tools such as Apache Spark, which is a very good solution coupled with Cassandra, and Cassandra would act as a very resilient and strong backing data store. But still, Cassandra itself is more OLTP oriented. So Okay. Yes, you can have auto retries at the driver level, and there are pretty sophisticated ways to handle that. You can configure them at driver level in your application code. Okay, so let's go. Let's say the normalization is now our friend. We know that we can trust it as long as we are in control. So let's assume we are in control and we go forward with where does the normalization lead us? Well, in the typical way you model your data to make your application run in a relational database, you start by looking at the data, you come up with entity and relationships between them, and then you design tables, and there is basically a single way to create the tables, the way that, let me say, reproduces the word, and then with an arbitrary amount of joins, you design the queries that suit your application. Right? Okay, forget about this. And let's think in a Cassandra way, which is basically the other way around. Because in a NoSQL, in particular, in the Cassandra way, you design the application, you start with the application, you start with your customers. So what are the workflows your customer will have in your application? Then you start by identifying these flows. What are the needs of your customer? What is the kind of interaction? What are the pieces of interaction between your customer and the application? This will make you design the proper queries, because every single interaction with the application will be a query, a particular query to get some data in a particular way. And once you are equipped, once you know the queries, you can design the tables. Again, because if you know the query, you can then find the right way to partition data. You can find the right column to put in the table, and you can design the table accordingly. All of these within the comforting blanket of denormalization. So that's very broadly described. Now there is a science behind data modeling. There is a very well-established workflow to approach modeling your data in Cassandra to create the tables for your application, and that's summarized by this workflow here, this flowchart. You start with two things. One is an entity relationship diagram, much similar to what you would do for a relational database. And at the same time, you think of the queries. You design, you look at the application flow, what is happening in your application. And this makes you, basically from this, you extract the queries that will have to be run on the data. Then mapping together those two things, you can end up with a logical data model. So basically every query will become a table, at least an idea of a table. Then through a process of physical optimization, you make everything a bit more precise. You decide the data types. You decide how to deal with particular kinds of special kind of columns, such as a column containing a set of strings or stuff like that. You make your calculations to avoid running into partitions that are too large or ever-growing or similar things. And then magically, you will have your tables in the form of create table statements. So very quickly, well, the conceptual data model part, which is one of the starting points in designing your data model, is very similar to what you have seen in relational approach. So you have entities which are bound by relationships, and every entity and relationship has some attributes. So we have, in this case, users, videos. User might comment on videos. A user has an email, a video has a description, a comment has a timestamp and a text itself, and stuff like that. Okay, so far so good. Then think of our ideal YouTube clone application. We start thinking of what happens when the user interacts with our application. So for example, the user might want to click on my profile and they want to see all of my comments. But then the user might click on a video and they want to see all comments on that video. And these two interactions of the user with the application correspond to two different queries, basically. Now, they are written as text, so something like find all comments for a user based on its identifier, most recent first. Okay, very good. This is basically a query, right? So indeed, the next step is to do mapping between those use cases, those application flow items, and make them become queries. Indeed, this query becomes something like find all comments for a user with a known ID, and that will become a table that we called comments by user, which we'll still have to design. But it will have to answer this question, this query. It will have to support this query. And this is where choosing the partition is important, because a similar query, number 2 here, find comments for a video this time. And we need a different table, even though the comments are the same. So the rows in the two tables will be the same rows, differently grouped, differently partitioned. And that's, if you remember, that was something you saw already in the practice part when you asked yourselves, why am I creating two tables? This is why. Indeed, the second table, called comments by video, will contain the same rows, but they will be partitioned probably by video ID because they have to support that particular query. And you remember that my query will always need to go to a single partition and get the data in the partition. Yes, each comment will be written to both tables. That's denormalization at play. It's very much less expensive to take care at the application level of the double write than it is to have joins on the reading side of things. And my application will be fast. I will not lose customers at this very small price of having a bit more storage and a bit more attention when I write the application code. Okay, so indeed, these two queries are actual queries that I can express in SQL language, as you see here. Basically, this is still an idea, but we are almost ready, and this is a process that involves the entity relationship diagram as well. I'm ready to make them become ideas of table, as you see here. This is the logical data model, and it is something that comes from comparing the queries and the entity relation diagram. So this is a special notation called the Chebotko diagram that makes it easy to identify what are the columns in the table, what is primary key, what is partition key. You see, actually, these two tables in the example have the same fields. It's just different how the partitioning is done. But anyway, then a physical optimization takes place, and then we decide that the user ID is a UUID data type. I will gloss on it. Comment is text and similar choices. So, but now we are ready because basically the table has taken shape and we have our create table statements. Ta-da! Nice. So this is a very brief account of how data modeling works. But you see, it's a process that starts from the application, which is the cool part in a sense, start from the needs of your user and ends up writing the tables to support the query. And usually every query will need a single table. But remember that storage is much less expensive than losing customers because your queries are slow. And I see a lot of cool questions, and I think I've seen also, Alex, you are lightning and you're managing to answer all of them, maybe. Very good. So we are now at the point where you can play a bit with the table, reading data, inserting data, changing data, and deleting data, which are the basic operations. So I will give it over to Alex for the practice.
Yep. Okay. So yeah, we have a great question by Virpan Talani. How will it make sure data is consistent between two tables? And short answer, you can use batches. Cassandra offer batches for cross-table consistency. But in short, you now have to care about cross-table consistency at the application layer. And in general, that's not really makes me happy. But we have to admit what Cassandra-enabled developers get better salary. And obviously, there is more work for me to do, but I can survive that as long as I get my money. So that's okay. Okay, so let me switch it back to my screen and we go to the next exercise. Boom, 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 boom. Boom. Yeah, so we are getting to the step 3, and that's going to be almost the last question, almost the last step we do today. That's going to be create part of the creation, so insert data and insert users. We have some tables, so now we are going to fill them. That's done with the insert statement. We will start by inserting 3 different users, and you know already that will make 3 different partitions. What's going on? So please don't leave the site. Okay. So first thing I'm going to do is I'm going to insert those 3 users. Those statements are basically the same. I will make it clear and I will paste these data. Users will be a little bit different. So now we can make a select statement. And oh, okay, we are still inserting. No, you know what? I want first to read. So I will do select all. Select all is a bad idea. Don't be like me. Don't do that in production. Select all. In this case, you may have tons of columns. That's definitely not what you want to have. But for these purposes, I will make it select all from users. Boom. And okay, I get my data. Looks like it was stored, and we are good. By the way, notice how Cassandra highlights, how SQL highlights your data. Email is red because it's a partition key, and name, password, and user ID are purple. I'm not so good with the colors, sorry. Name, password, and user ID are purple, mostly probably, because they are data columns. Good. So now we are going to put some data to put some posts. First, we will go with a posts by user table. And let me run this command. Boom. And second, we will post by room table. So I will simply copy paste it. I will put it here. Okay. So normally then you execute a query into 2 different tables. One query insert into post by user, second one in insert post by room. You can use batch. I won't use that in this case for the simplification. Let's say it's a little bit more advanced. So now we are going to read these data. I will go with a simple statement. I will just make select all from posts by user. I see those posts. And now notice one statement is red, one is cyan, blue, and room ID and text are purple. That's because room ID and text are data columns. You know that already. User ID is a partition key, partition column, and post ID is clustering column. You know that already. Okay, so, well, what we are going to do next? Now we can try to gather some data from posts by user table, okay? So what I will do, I run the query, select post ID, room ID text from post by user, the user ID, blah, 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 blah. I get my data. I have a user ID written in this post by user as a partition key, and therefore I can retrieve data from post by user table. But now take a look, what will happen if I do the same statement by posts by room? Wait for a second and think, what do you think will happen if I execute this query to the post by room table? Wait, think. I hope you came up with something because now I'm executing this query and boom, there are some red text. What kinda means what something wrong happened. Let's take a look at what's going on. I will make it even a little bit bigger for you. Invalid request. Okay, thank you. Error from server code 2200 invalid query. Invalid query. But you know what query is perfectly valid? Message. Cannot execute this query as it might involve data filtering and thus may have unpredictable performance. If you want to execute this query despite the performance and predictability, use allow filtering. Take a look. If I add this statement in the end, now my query is executed. Isn't that amazing? Hey, Stefano, I think I have to do it with all of my queries.
Yes, you solved the problem. Let's put
Yeah.
allow filtering in production and call it a day. Yes.
Yeah, sure. So, basically,
no,
what happens? Yeah, don't do it. What happens when we say allow filtering? We insist on Cassandra doing full cluster scan. And what is it in real life? I don't know about you, but when I order pizza, I specify my full address, the city, the street, the house number, right? And forcing Cassandra to do select without specifying the key, the partition key, like room ID in this case, it's like to order a pizza without specifying your house number, and then a poor delivery person will have to knock every door on your street and ask maybe if pizza was ordered from here. It is as stupid as it sounds, but you are smart, you won't do that. So take a look. First, the only thing you need to know about allow filtering. Do not use allow filtering. Second thing you need to know about allow filtering, do not use allow filtering. And the third thing you need to know about allow filtering, if you see someone in your team using allow filtering, please stop it. Because it's the best way to crush your cluster performance to the ruins. And you don't want to have it. So do not use allow filtering. Well, we are going further on this step, and now we are going to get some data. Okay, so we got this post by room table data. And of course, we can get some data with post by room specifying the room ID. So how do I adjust this query? So it will be working. I have to specify not user ID, but I have to specify room ID, right? So I will go for it, and I will do room ID equals, let's say, running. Where did I do the mistake? Select post ID, room ID, text from post by room, where room ID equals running. Okay, that was simple. Double quotes. Again, that hit me again and again. Okay, so this time the query works without any allow filterings. And basically, we are all good. So we get our data. And the final thing we want to do, since we use the time UUID for our post ID field, and we still need to know the time of the post was created, we will use a function date of to extract the timestamp from the time UUID. So I will grab this thing and I will paste this statement, and we are getting this post date, which doesn't exist in the table, but now exists in the output because I use a date of, and now I have the date. Cool. So we are done with that part. Are there any good questions?
Yeah, there is a very good question, but I'm answering in the chat, but maybe, yeah. So what happens if two batches update a record like total amount? And well, the answer is, that's a very good question, Andrin. The answer is that this is a very particular use case where you want to do what is called a compare and set application query. So it's a special kind of query that actually involves some kind of transaction, a micro transaction. It's called lightweight transactions. Those are possible in Cassandra, and they come with a performance cost because they necessarily involve some sort of coordination, and you have to use them when you need them, but not more than that, because otherwise you are killing your performance. But yes, there are some cases where you need to coordinate access to a row, like total amount indeed, and you can do them. So you can serialize the operations on such a row.
Okay, right. So now we are going to update data. So to change something. And now we are going to change something. So in this case, we will update posts by user and specify new text. And notice what now we have to specify both user ID and post ID. Why? Answer is we must specify user because user is a partition key. And we cannot execute the query without specifying a partition key. And then we have to specify post ID because if we won't specify post ID, this text will be applied to all records in this partition. So that's why we specify partition key and clustering key. So let's do that. I will run these posts by users and select the data from it. And we see what it was updated successfully. Well, not a big surprise. Next one. We will insert some more data now. That's important to understand. In Cassandra, as it uses upserts, if you're familiar with Mongo, for example, you know this concept already. Update and insert are the same. Moreover, I will tell you, even delete is the same, but that's a special secret if you want to learn it. How come delete is the same as update and insert? When you will have to go to the academy.datastax.com to learn how it works internally and why delete is the same as update. We are going to write these data, but this time I will use insert instead of the update, and we will see how it looks like. And I'm executing this statement, and we see what there are not a new row added, but instead of that, this row was changed. This one AAA row was changed to, and Mount Goomba was not so easy. Why? I told you insert and update from Cassandra point of view are mostly the same. Cool. So, where do we go? Well, last thing left for us is to delete the data. Delete the data is basically we are doing that with delete statement. So that's not a big surprise. So we can do these statements. And I will clean it up a little bit and now execute them. So we can walk back through it and see how it was executed. So we select, we do delete, we do select on posts by room. We have 4 strings here. And then we do delete from posts by user, like user decided to delete his posts. And we delete and we delete and they get the results. Finally, in the end, posts were deleted. So quite predictable. One very important point, which will be explained at the Academy, but in short, if you want to delete everything from a table, you better not do delete, but truncate. So you can totally do oh my God. Truncate, table, post by user, and it will result, okay, I don't have any users anyway, and that will be like that. table is empty, of course, but this way deletion is more optimized if you have to wipe out your whole table, of course. Um, there is a question, great question by Sajal Gayal. Are there rollbacks? That's amazing question. And take a look. In short, answer is no, for a very simple reason. If you have like some theoretical knowledge in this field, you know already what any kind of transactions, especially transactions what require rollback, require locking, optimistic locking, pessimistic locking. But anyway, there are some parts of a table or even a whole table to be locked as long as transaction is not executed. As long as your database fits to a single machine, and as long as your data fits to a random access memory, it can work, and it can work lightningly fast. But then your data is spread at over dozens, hundreds, maybe thousands of servers. Any attempt to execute a lock, and without lock, rollback is not possible. Will basically destroy any performance of your cluster. And Cassandra was designed to support highest level of the performance, like very single digit millisecond performance over petabytes of data. Basically, you cannot afford any kind of locks over this data. Otherwise, it will be destroyed. So, short answer is no, you do not have rollbacks in Cassandra. There is a way to do read before write and do not execute insert or update or delete statement in case you don't want it to be executed. It's called lightweight transactions. But even in this case, we do not speak about rollbacks. We are speaking about checks before writes, which is a very different concept, which doesn't require locking. Okay. So it was a great question, by the way. Now we are done, and I'm switching screen back to Stefanos, right?
Very good.
Boom, boom, boom. Boom, you are live.
So thank you. So I have to say, I've been looking at the chat, and congratulations, because there are a lot of very interesting questions today. So it's been a very cool discussion going on as an aside. But I hope in the meantime, you've been able to ride through the CRUD operations with Alex, because that's the basics, how to interact with Cassandra on the SQL with the SQL language. So it's all very cool, and I hope you had fun. The fun is actually about to start, because we've been done with the theory. We are done with the practice, and now it's time to play.
All right. Okay. So you know what?
Sorry, I have to laugh.
And I'm switching back to my screen.
Somebody asks me if I am in any way related to Lionel Messi, and no. If you see me play football, you know that the answer is no. But funny thing, many years ago, I was in a German pub, and I was mistaken by Messi by a group of very convinced drunken Germans who went as far as to ask me for an autograph.
Unbelievable.
Yeah. Nice.
Okay.
It was nice.
Yes.
Sorry.
Yeah. That's quite cool story. You didn't tell it before. Okay.
Yeah, many years ago.
So. Well. So let's take a look. We go now to the quiz. What does that matter? It means what we go for a game. And in this game, we ask you the questions. You answer if you do it fast enough, and if you give the right answers, you have chances to win the prizes. And that's amazing. So let me see if we have 70 people on YouTube, and we have 74 people on Menti. That's okay. If you are not with us on Menti, then jump up right now. You won't have a lot of time. Go to menti.com and enter the code 83062966, or scan the QR code next to Stefano, and we start in a moment. Please pay attention, don't miss a word. And Tom Mongo, regarding the certification, don't worry, we will say a word about that after the quiz. So I'm about to start, and that's going to be quiz time with Alex and Stefano, and we are getting to the first question.
Oh yeah.
Just few seconds, I'm giving everyone a chance to join. Now please notice YouTube has a slight delay, so if you want to have higher chances to win, to answer fast, focus on your mobile phone or whatever you use to open Menti, okay?
Yeah, absolutely.
And we are go. I hope you are ready. So, answer fast to get more points. How many master nodes does Cassandra cluster need? At least 3 per cluster, 3 per data center, enough to maintain consistency. Not a single one, Cassandra is decentralized. Okay, question number rises quickly. And time is up. So, how many master nodes does Cassandra cluster need? Right answer, not a single one. Cassandra is decentralized. The very concept of a master does not exist in Cassandra. Cassandra is a true democracy. It doesn't need any masters. And answer 3 per cluster is definitely wrong. So let me see the leaderboard. Hey, Thomas was the fastest. And Kelvin following, and Hina Pankaj is also very, very close. But the battle only begins, so we have more questions for you. Now it's going to be question number 2. So get focused and answer my question. Answer fast to get more points. How data is being distributed in a Cassandra cluster? All data is replicated to each server by partitions, range of partitions per node, with address locators using the post mail. Chat is so quiet, everyone is focused on Menti.
Yeah.
Totally makes sense. Totally makes sense. And time is up. So,
Let's
time
see.
is up. Sure, data is distributed by partitions, range of partitions per node. It's not like all data is replicated to each server. Take a look. Apple handles hundreds petabytes of data. They
Good
would
luck.
go bankrupt. Good luck with that. Good luck copying all data to each server. They will go even Apple would go bankrupt doing things like that. It just doesn't work. By partitions, and each server is responsible for the range or partitions, for part of the partitions. Okay, who made a mistake? And who is fast enough to get on top of the leaderboard? Looks like Thomas wasn't fastest this time, and Kelvin takes over, but Sampath Karumudi was the fastest, getting directly to a 4th place. That's quite cool, and Andreas Haas holds the 3rd place. Well. Question number 3. I hope you learned what to do. Answer fast to get more points. Which replication factor is recommended? I told you a couple of times today already, well, but mostly in the chat. So those who read the chat will have higher chances.
I also said that a few times. So
okay,
everyone has a chance.
That's good. That's good. Which replication factor is recommended? Time is up, and the answer is 3. And that was quite simple. No one votes for 15 or even 42, which is sad. But that's an interesting option of 1.5 server. It's like 1.5 bit or something. Like, I cannot really imagine that.
Well, the half server would probably not work, depending which direction it has been sliced, but I'm afraid it will not work.
In Cassandra version 4, actually, there are cheap quorums with transient replication. We can partially relate it to 1.5 server, actually. I've just realized that.
In a sense. A bit of a stretch, however.
Yes, good. So, Hina Pankaj gets to the 1st place, and that's a great performance. And Sai Sampath is on the 2nd with Kelvin on the 3rd. Thomas was fastest again, fastest train on the planet, the fourth place, which is still very good, and only 6 points difference to the third place, but only first, second, and third places are getting the prizes. So Thomas, keep fighting. And we have Mars here, God of War. So that's going to be interesting, and we still have a lot of questions. And that is, ladies and gentlemen, question number 4. So answer fast to get more points. What is AstroDB? Is it maybe a gateway to the stars? Is it a local in-memory version of Apache Cassandra? Is it a Cassandra as a service in the cloud? Or maybe it's a development tool like your IDE. What is it? Yeah, chat is totally quiet.
Absolutely. Everyone is unmuted. That's good.
Yeah. AstroDB as a Cassandra in the service in the cloud. It is not a local in-memory version of Cassandra. It's a cloud persistent version of Cassandra for sure. And it's not a development tool. That is for sure. Good. Yep. So, any of the leaders to make a mistake? No, our leaders are doing well. So I see Varun had great questions today. Thank you, Varun, for the great questions. Aldrin, now some familiar names. Animesh, all cool. And Thomas is fastest again, jumping to a second place this time, right between Hina and Sai, with Kelvin on the 4th place. Something is going to change after this one, and that is question number 5. So answer fast to get more points. What is a primary key? Same as partition key, it's the main house key. Does not apply to NoSQL databases. Uniquely identifies a row. It is a column in the partition key. Okay. Time is almost over, and
I hope we stressed this point enough. Let's see.
Well, still, those with the best results will get the prize. And yes, it uniquely identifies a row. It's not the same as a partition key. It can be the same as a partition key, but actually, partition key is just a part of a primary key. It's not the same. Show me the leaderboard. There should be someone doing mistakes, but none of our leaders made it, so all of the leaders answered correctly.
Very well.
Kelvin was the fastest, jumping to the 5th place and moving some path down to the 4th. Well, he is still able to fight for the first 3. Fight on the top position on the leaderboard. Good. So, let us move on. That's a close, that's a tight fight, like everyone is close, and there are many people who are ready to jump right on the top 3 of a leaderboard. Question number 6. So, to get more points, answer fast. What is the partition key then? Is that a consecutive number applied to each new record? Maybe it is a designated field in your table to partition your data? Is it an optional table field for optional partitioning? Or maybe it is the key to partition this reality from the next?
Whoa.
Is it something like, sci-fi? But most of you made it. Partition key is a designated field in your table to partition your data, and that's the right answer. It is not optional, it's required.
Absolutely.
And it's not a consecutive number, because take a look. You can afford consecutive IDs and consecutive numbers like in Postgre or MySQL if you have a single host database. But when you have a dozen of servers or maybe 100 of servers, they all will have to agree which number is next. Just issuing an ID will take a minute maybe. So that's not what you want to have with your distributed database.
Yeah. On a large-scale distributed system, the thing you really don't want is unnecessary communication and coordination between nodes. So no sequences there. In Cassandra, no sequences available.
All right. Well then, how is going with my leaderboard? No one made a mistake.
They are too good. It's really a race to the millisecond here.
Next time
Come
we have to
on.
make it complex. Here, Thomas is
Yes,
back.
harder.
Thomas is
We
back.
want harder questions.
Yeah, we need to have harder questions. Now the fight for the first 3 places is still hard. And hey, by the way, hello Rakhavan, welcome to the top 10. With the fastest answer this time. That's already great. Now, next one. And that's going to be question number 7. So we are almost on the finishing line. Answer fast to get more points. Executing select query without the partition key is the recommended way to retrieve data, the right way if the data was inserted without the partition key, a way to full cluster scan, illegal and punishable by law. We have
I'm paying very much attention to the answer to this question.
Right.
Know that.
Right. You know, if a lot of people will give a wrong answer, we will be fired.
Yes.
At least we deserve to be.
Please.
Okay, so most of you gave the right answer. Executing select query without a partition key is a way to full cluster scan. Great news, we can keep our job. And
Very
that's
well
totally
done. Thank
correct.
you, guys.
There are 5 people answered it's illegal and punishable by law. And it's not, sadly, but it should be. So I'm totally with you. It should be illegal and must be punishable by law. I'm with you guys. I believe it is the right answer. And data cannot be inserted without a partition key, and partition key cannot be null. So you cannot insert data without a partition key. And it's for the 100% not recommended way to retrieve data. Well. You know, fire my mouse vendor for misclicking. NoSQL police is after you, run. May I be in the NoSQL police? I can be very good in it as an investigator to make interrogations. Were you using allow filtering in your last project? No, sir.
We found the traces of allow filtering on your fingers.
Okay, this one is great.
Nice. Sounds nice.
Oh, guys, you make me laugh so hard.
We might make a small movie on that.
Yeah, right. That's a great idea. NoSQL police, bad boys. What you gonna do? Well then, so leaderboard 1 step before the end, and there are no huge changes, but there are some. Thomas was the fastest. Good job. That's the 2nd place. Hina keeps the 3rd. Kelvin is on the 1st, but with a minor difference. Rakhavan made it to the 8th place already. Good job. And Green is on the 6th place now. The last question defines everything. I bet the leaderboard, all the top 10, is really nervous now. Maybe some of the winners, maybe some of the top 3 of the leaderboard will make a mistake. It happened yesterday and it can change everything.
Yes.
Well. Now even I am now a little bit nervous and I know the answer.
The air is electric now. Last
question. Right. So electrized. So question number 8. And I'm starting the countdown. Answer fast to get more points. In the data modeling framework, we start modeling with conceptual data model and application workflow, physical data model, logical data model, copy-paste from Stack Overflow. Well, Stack Overflow is a good friend to all the developers, but in this particular case, I wouldn't trust it, frankly speaking.
Yeah. You're giving away?
Boom!
Let's see.
Okay, so most of you made it right. Physical data model
done.
is the last step, and logical data model is the 1 step before physical data model. But we start with conceptual data model, so entity relationship diagram, and application workflow, so workflow diagram. And we get to that. None of the leaders made a mistake. And Hina was a little bit faster than Kelvin, but there are no changes on top of the leaderboard. Kelvin makes the first place, Thomas the second, and Hina Pankaj the third. Now, leaders, please make a screenshot of your top of your place and send it to Jack Fryer at jack.fryer@datastax.com. We will show his email in a moment. Congratulations to the winners. And take a look.
I put the email already in the YouTube chat just for reference.
Yep, thank you.
Sorry.
So, if you are on top of the leaderboard, first 3 places, we do congratulate you. It was a great fight. And if you are on the leaderboard, you still have a solid reason to be proud of yourself, because it was quite a competition of dozens of people, and you're still on the leaderboard. And if you are not on the leaderboard, still don't take it too serious. First, we do workshops every week, so you have chances to win your prizes next week. And well, you know what really matters is your knowledge. Knowledge is what makes you better. Knowledge is a true power. And today you learned something new which made you better in what you are doing. That will help you get a better job position, better job title, better salary. So that sounds quite good to me, even if you didn't won the prizes from DataStax.
Yeah.
I will open the window to get your feedback. What did you like the most in this workshop? What should we improve? And I will keep this window open so you can write your answers afterwards. But now we switch to the very last slides of Stefan.
Oh, yes, please. By the way, there is a question, what is exactly in the gifts? And I'm afraid I'm not sure, because there is some rotation of the gifts. It's probably, well, there should be a t-shirt, probably a mug. I don't know exactly what. Some DataStax swag, for sure.
Yeah, I don't remember. Maybe Cedric knows, he can explain in the... okay, I'm switching to your screen, and by the way, thank you for your amazing feedback. That's very that's very nice of you.
Heartwarming.
Yeah. Okay, so you are on the screen.
Okay, thank you. So, okay, again, the 3 of you who made it to the first 3 positions in the game, please send a screenshot of your winning screen to Jack Fryer, and he will get back to you to arrange for the swag. But let's go back to topic. So you've seen tables, partitions, data modeling, a lot of stuff about Cassandra, and what's next, you might wonder. Well, first thing, please go ahead and complete the homework, which is some exercises in the README, plus go into these 2 interactive scenarios and play with them, do the practice. You will learn even more about data modeling and SQL. Take a screenshot of the final congratulations screen and get ready to go to the submission form and give them all to us, and wait a few days for us to grade the homework and give you your nice, well-earned badge. Now, that's not the end of the story, because you might want to visit datastax.com/dev for even more information, more stuff about Cassandra, developing application, data modeling, all stuff, administration, whatever. And there are also other hands-on scenarios to experiment, to do practice in your browser, and a lot of stuff. Now, something that we already mentioned, DataStax is very happy to sponsor your education and your certification. So we want you to get Apache Cassandra certified. And to do that, to all of you who attended today's workshop, we are offering a voucher to go and take the exam for free and get certified. Now, that doesn't mean you don't have to study, because there is some learning to do. Otherwise, the certification would not have the value it has. But still, the exam itself, which has a cost, is on us. So please go to this link, dtsx.io/workshop voucher. I might drop it here as well. Go there, and you will be able to. I don't find it here. No. Alex, can you paste it into the YouTube chat, please? The workshop voucher link. I don't find it too easy to copy and paste. Thank you.
Sure.
So you will be able to get your voucher, and that will give you a chance to take the exam for free. That's about the academy. And just a quick mention, there are 3 different learning paths in the academy, one more aimed at developers, one aimed at administrators, and then there is also another one on Cassandra, which is, as I mentioned time ago, Kubernetes distribution of Apache Cassandra. So the academy will offer you courses for free. There is a common part, fundamentals of Apache Cassandra, that goes more in depth on what we saw today, basically. And then there are various specializations depending on your learning path. And then you will be able to take the exam for free. Okay, so what's coming next? Because, we run workshops, at least 1, usually 2 per week. So next week, there is a very cool workshop about building an e-commerce application. So you are invited to go to datastax.com/workshops, register, because it's going to be fun. Trust me, cool and fun. But even more important, next month, that is during the full month of January, we will have a bootcamp, a 4 episodes bootcamp that will guide you through the whole process from introduction to Cassandra, which will be mostly today's content, all the way to building and designing an application. And that's going to be cool, and it will give you a lot of knowledge and practical know-how to be able to start your own application. And by the way, when you start writing your application and dealing with Apache Cassandra and using it, we would love to hear back what you did, because we are obviously very interested in looking what is the usage of Cassandra out there. And we are always proud to showcase, if you agree, to showcase what you are going to build. So the best thing to do is you connect with us on Discord maybe, and we would love to hear what you are building, or to give you guidance or help or whatever might come up. That being said, please subscribe to our YouTube channel and have a look at datastax.com/workshops to get informed of the many workshops we are running, because we do stuff on application development, various languages, various technologies, and obviously Nosql databases as well. So another thing is that we have this Discord channel I mentioned already, so dtsx.io/discord. Please join us, because that is where most of the discussion is going on, especially for long-term help and assistance and chat, whatever, if we want to get to know each other better. So join us, and I think with the final plea for subscribing,